Hey everybody, here is section 2, Newton's laws of motion. This video will be much shorter than the other one. So here is our scientist, Sir Isaac Newton. He is the one who supposedly sat under the apple tree and started writing about gravity after he got bonked in the head by a falling apple. He has 3 specific laws we're going to cover, and there are cheesy gifts involved, so let's get started. Maybe. There we go. So his first law is also called the law of inertia. And this basically says that an object at rest remains at rest and an object in motion remains in motion unless it is acted on by an outside force. If we were in school right now, after showing you this definition, I would chuck a marker at the wall. Okay? And what would happen is that marker would keep going until something else stops its motion. And it could either be the wall that gets in the way and provides a force. It could also be gravity that brings that marker down to the ground. The opposite is also true. If there's an object sitting in the room, like, a water bottle or whatever, it's going to, if it's at rest and not moving, it's not going to move. Unless it's, a living thing and has that option. But something that's just sitting there on my desk, that is at rest, it will not move until I come along and knock it over, right? Until an outside force causes a change in its motion, okay? Another word you need to be familiar with is the word inertia. It is the tendency of an object to resist a change in its motion. The more mass an object has, the more it can resist movement, like when we had the empty water bottle and the full water bottle. If you flick both of them, one of them is going to go a lot farther, the empty one, right? Now, this law, Newton's first law, is also why you should be wearing a seatbelt. If the car is suddenly stopped, if the car's forward motion is suddenly stopped by the brick wall, well, your body still has that forward motion, but it's not technically part of the car, obviously. So your body, the inertia of your body will launch you over the brick wall if you're lucky to be that graceful. So the seatbelt is what helps to stop that forward motion and keep you inside the car. Okay? Second law, also called the law of acceleration. If you were to just write out this equation, or one of these equations, technically speaking, that is the law of acceleration. And the way to think about it is, if you're talking about forces, mass, and acceleration, so we have newtons, kilograms, and meters per second squared. If we assume that 2 objects are traveling at the same acceleration, so I have 2 meters per second for both our football player and our tiny little baby puppy, okay? Now, they are obviously going to generate very different forces because their masses are so very different. Our football player is going at 130 kilograms, that's roughly 280 pounds. He's going to generate 130 times 2, 260 newtons worth of force. Okay, I know 0 8th graders that could withstand that amount of force. All right. Now this little guy over here is a little different. He only has 2 kilograms, and that's probably being generous. That means he weighs maybe 4.5 pounds if he's lucky, soaking wet maybe. Running at the same speed as the football player, he's only going to generate about 4 newtons of force. That is probably a force most middle schoolers would welcome. Look how cute he is in his stubby little legs. Okay, so just getting you to think about how if something's at the same acceleration but they have very different masses, the force produced will be quite different. And you could start playing around with any of those numbers to see how changing one variable affects the outcome. Newton's third law is also called the law of action-reaction. This basically says that for every force, there is an equal and opposite reaction force. So if you push off of the water when you're swimming, the water is actually pushing back on you, and that's how you glide through the water. This is how rockets work. The force on the hot gas, that's the action force. It's pushing that way, and the reaction, the force on the rocket is what is going to propel that rocket forward. And this crazy professor dude over here is showing you how that works with a fire extinguisher and a skateboard. Do not try that at home. You do not have permission to use up a perfectly good fire extinguisher. Deal? But you could build your own little car or cart, maybe with a little matchbox car and a balloon or something, that could, yeah, you could definitely play around with that. If you've ever stubbed your toe, I think we talked about this in class one day. The reason your toe hurts is because you basically kicked the wall or whatever. The wall kicked you back, and that reaction force is what you're feeling on your toe. Okay? This is how we move through the world. If we didn't have this force, we would not be able to navigate our environment. So that's it for these laws. They're a lot of fun. Be on the lookout in Google Classroom for more fun labs. And there are some more slides within this Google Slides presentation, but we will not go into those for now. So I hope you have a lovely day. Make sure to write down the notes.